Thanks for coming to this special evening event. I'm Kathy Whitlock, and I'm director of the Institute on Ecosystems at Montana State University. The institute is a statewide institute, so there's a hub at University of Montana and a hub at Montana State University. And it's my pleasure tonight to introduce Dr. David Titley, who's a professor in the Department of Meteorology at Penn State and also director of the Center for Solutions to Weather and Climate Risk. And I love that topic. Are we ready to go? Okay. Before I tell you more about Dr. Titley, I wanted to let you know that MSU, there's several people and groups that have sponsored this lecture tonight because there's a real interest at Montana State University in climate change and climate change research. So this event's been sponsored by MSU's Department of Political Science, Department of Land Resources and Environmental Science, Department of Earth Sciences, the College of Letters and Science, the College of Education, Health and Human Development, the College of Agriculture, the Campus Sustainability Advisory Council, the MSU Leadership Institute, the Montana EPSCoR program, and the Montana Institute on Ecosystems. And I also want to acknowledge the sort of driving force, the unsung hero in this event, and that's Paul LaChapelle, who I think is in the back of the room. Paul is an associate professor of political science, and he's also the MSU's Extension Community Development Specialist. And Paul is really responsible for extending the invitation to Dr. Titley. And I should say that this past spring, under Paul's leadership, 4 teenage girls from Montana, all members of Montana 4-H, traveled to the Teen Climate and Environment Summit at Rutgers University. Their goal for going to this meeting was so that they could get ideas for starting their own climate and environment summit for teens here in Montana. These 4 young women, and we have one of them here today, Alexandria Schaefer. Can you stand up? Alexandria is from Denton, Montana, and she was joined by Rachel Fessenden of Bozeman, Shelby Fitzpatrick of Cutbank, and Jenny Grieger of Bozeman. And these women care deeply about Montana's environment and want to make our state better for the future. So Paul invited Dr. Titley to visit Bozeman, and he believed that Dr. Titley's visit would be a catalyst for helping have meaningful discussions about climate change and helping Alexandra, Rachel, Shelby, and Jenny take the next step toward getting teens and also adults to talk about the future. So we're really proud of them. Now, Dr. Titley is a nationally known expert in the field of climate, the Arctic, and national security. He served as a naval officer for 32 years and rose to the rank of Rear Admiral. His career included duties as commander of the Naval Meteorology and Oceanography Command, oceanographer and navigator of the Navy, as well as Deputy Assistant Chief of Naval Operations for Information Dominance. He can tell you what that is. While serving in the Pentagon, he initiated and led the U.S. Navy's Task Force on Climate Change, and after retiring from the Navy, he served as the Deputy Undersecretary of Commerce for Operations and the Chief Operating Officer at the National Oceanographic and Atmospheric Administration, that's NOAA. Dr. Titley's spoken across the country, his calendar is completely filled with speaking engagements, as I understand it, and also throughout the world on the importance of climate change as it relates to national security. The Department of Defense requested he present on their behalf at both congressional hearings and at the Intergovernmental Panel on Climate Change, the IPCC, from 2009 to 2011. So we're really pleased to have him here. Welcome, Dr. Titley.
Okay. Thanks. Okay, thanks very much, guys. Can you hear me on this mic? Yes? Okay. I've got to figure out where I stand so I can see you, and I'm not blinded here. I hate standing behind these things, so I'll wander around a little bit. Dr. Whitlock, Professor LaChapelle, thanks so much for asking me to come out here You know, I shouldn't tell you guys this until I submit my travel claim, but you know, the truth is I'd come to Bozeman for free. I'd pay to come to Bozeman. It's a wonderful, wonderful place. My wife and I have been here, I don't know, a half a dozen times. You know, I've come through this auditorium maybe 5 or 6 years ago, and I wouldn't have put 1,000,000 to 1 odds that I would ever actually be, you know, speaking. And did Paul offer you guys free beer? Is that why? I mean, this is great. This is really, really wonderful. So, and it's a spectacular space. So really, just a hat tip to the Museum of the Rockies here. I mean, what a facility! It's really, really something I'm sure everybody here is very proud of. You should be. 2 things. You know, there's a good thing and a not so good thing about this room. The good thing is, the great thing is, the acoustics are really, really good. The not so great thing is the acoustics are really, really good. So if you guys have sidebar conversations, I can hear them, and I might ask you to share them. So just so you know how all that's going to go. Okay, we're going to walk through this. I'll be happy to take questions at the end here. You know, it's 45-ish minutes, give or take, something like that, and we'll go from there. Okay, but what in goodness name, does anyone have any idea what this thing is up here at the very beginning? Looks kind of grody, I have to admit that. Sitting back behind a laptop running a weather station. It's a rain gauge. It's a rain gauge. It's an old rain gauge. This is pre-tipping bucket. This is all pre-that. I got that when I was 10 years old. I was living in Jamaica, West Indies at the time, because if you put a 5-inch funnel, so you go down to the market, and go talk to the tinsmith, and he'll make you a 5-inch funnel. First he made me a 4-inch funnel, then a 6-inch funnel. The third time we got a 5-inch funnel. I'm sure he was wondering what some snot-nosed 10-year-old, like why did it really have to be 5 inches, but that's what this is calibrated for. I have my mom, if my mom was here, she would tell you that I hatched as a meteorologist. I've just always been interested in weather. And you know, I just always have. So I have, you know, I'm not going to bore you with it, but I mean, I've got, you know, records of the weather observations from when I was 8, 9, 10, 11 years old. The other thing I found out is I was a whole lot better at weather modification than I thought I would be, because as soon as I finally got this and I got it set up at our home in Jamaica, we had the biggest drought we ever had down there when we lived there. So it's like, okay, so that all worked. So, you know, I never thought I'd be talking about climate or talking about communications on this. I just wanted to be a forecaster, a weather forecaster. So nowadays I'm a recovering weather forecaster, and that's kind of what I do. So, as I said, I did that, and I ended up going to Penn State University. And the reason I picked there is because, at least in the Northeast, and I would argue it's one of the top in the country, it's got a great meteorology or weather program, and it's really attuned to operational weather forecasting, and it's what I wanted to do. So I showed up there, and I found out that, geez, I wasn't the only person who had this weird affliction. You know, there were actually a number of other of us just like that. I would love to tell you that's what it looked like in 1976. It's what it looks like in 2014. It is really cool. If anybody gets out to State College, come look me up. I'd love to host you. But when I was there, it was a little bit more like that. And yes, I could plot surface observations, and I could do it faster than the teletype. That is a skill right up there with like buggy whips. Nobody cares. Nobody cares anymore. And then I ended up in the Navy. And I would love to tell you that the reason I was in the Navy is because I could trace my lineage back to John Paul Jones, and I would be 7th generation, and it would be wonderful. The truth of the matter is I ended up in the Navy is because I needed money to pay for college, because we didn't have a lot. And my parents said, hey, you want to go to college? Great, good on you. Go figure out how to pay for it. And it was post-Vietnam, so I was able to sort of squeak in under the wire. I'm not sure I would even get in today. But I was able to join the Navy, and the deal was they would give you a scholarship, and you owed them 4 years. So I said, okay. So I was on what I called the 4-year and a day program, because I'm a great guy. So I was going to give the Navy 1 extra day, and then get out and go do this stuff, go do weather. It turns out I actually kind of like driving ships. I like doing weather forecasting at sea. The Navy, for reasons they would have to explain to you, thought I was at least minimally competent at doing this stuff. So my 4-year and a day program turned into 32 years, and I ended up as oceanographer of the Navy. So I was running the Navy's operational weather, ocean, surveying, doing all that kind of stuff. Our headquarters are down in Mississippi, very happy doing that. And as I was on the road, actually to the New Orleans airport where I flew out of, I got a call from this gentleman. And my guess is not too many people know who this guy is, but maybe somebody does, or if who's been prior military? There's at least a few in here who are prior military. So look at this guy's shoulder boards. What do you see there? 1, 2, 3, 4 stars. Okay, so he's fairly senior. Turns out he was actually the senior admiral in the Navy at the time, a guy named Gary Roughhead. So my assistant, basically, we're driving over one of these big, long bridges over Lake Pontchartrain, gives me the phone. It's like, sir, it's the CNO, Chief of Naval Operations. It's like, what have I done? And I'm sort of thinking, well, geez, this could be good, or it could mean that I'm going to go home and tell my wife we're going to look for a new job starting tomorrow. I'm not quite sure. Well, Gary Roughhead asked me, basically, he says, hey, Titley, I need you to get your butt up to D.C. I want you to become the oceanographer. I'll make you a 2-star admiral, and go figure out this Arctic stuff. It's driving me nuts. There's a lot of people saying there's a lot of change. I don't know what's going on. Go figure it out. So that was like late April. No, it was late March, excuse me. It was late March. 5 weeks later, I'm in D.C., sell our house. Selling your house in early 2009, that's fun too. That's another story, though. That's a different story. So I get my first day in the Pentagon is the 1st of May. On the 15th of May, I'm basically briefing the corporate board, all the 3 stars and this guy and his other 4-star, on what we should do. And that's how we started Task Force Climate Change, basically to get a handle of this. So I was able to convince the Navy that the Arctic is sort of the leading indicator, the leading symptom of, hey, there's some big changes coming and we need to get out ahead of this issue. So he gave me like the best set of orders I ever had. He said, Titley, I want the Navy to be seen as showing national leadership on this issue. That's all he told me. It's like, what a great set of orders. I mean, it's perfect. It's like, you can run amok and like really do all kinds of damage with a set of orders like that. Okay, so that's how, kind of in a nutshell, I ended up here. And yeah, we're going to talk about climate change, and all kinds of cool climate change geeky kind of stuff. We'll do a little bit of that. But I would ask you, ladies and gents, as I talk about climate, to kind of see this as one of, not the, but one of the driving factors of the 21st century. But there are other equally important, equally big driving factors. And oh, by the way, none of this stuff is like independent. It all either influences or gets influenced and kind of either exacerbates or tamps down some of these things. So I'll just go through them really quickly. But, we're doing this with a world of, 8+ billion with a B people. Now out here with all the producers and the farmers, you guys are feeding them. So you know that. I mean, and that population right now is still going up. A lot of people think by the end of the century it'll start kind of leveling off, but right now we're still going up. We're still going up pretty fast. Those folks, including you and me, very rightfully want, demand, and expect adequate food, water, energy. Oh, by the way, the more you look at those, the key thing of all that is the water. Because without water, I mean, everybody here kind of gets you're not going to get food. But also, most forms of energy are actually really water intensive. So the water is kind of a big deal. And not only as we have more people, but as more and more people kind of move into the middle class, you tend to use more energy, you tend to eat more calories, so you use more of this stuff. Whether we like it or not, we're in a globalized world. So it's really hard for us to, sort of build a wall, if you will, around America. It says, hey, if Asia has problems with storms or sea level or whatever, well, kind of sucks to be them, but too bad. I mean, it just doesn't work that way, because we get, unless we don't want these things anymore, because, where are they made, I mean, parts are made all over the world, and they're, kind of assembled. The intellectual brain power for designing it may be in California, but we build them all over. And you can find, countless kind of examples of that. This is kind of a geeky graph, I admit that. This is something called Moore's Law. Anybody heard of Moore's Law? A bunch of you probably have. Basically this idea that roughly every 18 to 24 months, for a same amount of money, you can buy twice the amount of processing power. guy who ran Intel in the 60s came up with that, and so far that seems to still actually apply. Well, that means that, all these 8 billion people, I mean, you get the internet, you get the kind of processing power, you get social media, it drives transparency. So again, if we say, hey, so sad for those guys, well, guess what? We know what's going on, they know what's going on here, so we have all of that. And then finally, these debonair gentlemen here, European finance ministers, and now you're probably thinking, Titley's really lost his marbles now. Why does he have European finance ministers up? I thought I was going to hear a talk on climate. Why? Because we've got all these issues, including climate, and our self-talk is, we're out of money. So we're going to deal with this, at least according to ourselves, we're out of money. I had the opportunity earlier today to talk to some of the Montana State Mideast students. And they really brought up, I mean, I didn't have any of these slides, they brought up on their own, hey, the whole financial crisis, we were kind of going to do okay, and that has really, really hurt our ability to respond to either climate or other problems. So, we've got climate, demographics, resource competition, globalization, technology, and its drive to transparency, and we're going to do it in, if I was back in the Beltway, I would call it a fiscally constrained environment. Fancy Washington speak for we ain't got no more money. So that's kind of what that is. So here's just one of those challenges, and I put this in again because of course, agriculture is so important out here, it might be a little tough to see. And I've got to give full credit to a guy named Dr. Jerry Hatfield. He runs the U.S. Department of Agriculture, Maine environmental lab out in Des Moines, Iowa, or excuse me, Ames, Iowa. Jerry very kindly loaned me a few slides, so when you see a USDA logo, those are his. But kind of big flick, if you will, we've got to generate more calories. We, the agricultural enterprise, need to generate more food calories in the next 50 years than we've generated in the previous 500. So, I mean, that alone, you just take away the climate stuff. That alone is a pretty significant challenge. Oh, by the way, we're now going to do it in this changing climate here. So, okay, so here's kind of my bottom line on climate. You've all heard of these IPCC reports. How many have read them cover to cover? Cover to cover, okay. I'm keeping my hands down. I haven't done that. I read the summaries, I read pieces I need to read. National Climatic Assessment, that's a lightweight. That was only 1,100 pages. Who's read that one cover to cover? Okay, I haven't either. So here, climate change in one slide, kind of all you need to know. This really is about people. This is not a polar bear. This is not an environmental issue. I don't say this to antagonize the environmentalists, and I'm sure we have some either environmentalists or people representing environmental groups here. But I look at this as an issue that affects me, my family, my wife, my fellow citizens in Pennsylvania and State College, certainly in the country. I lived on the Gulf Coast. The sea level rise is a really big deal. The hurricanes are a big deal. This is about people. It's not about polar bears. Since I have no life, one Saturday evening, I Googled climate change and clicked images. And then again, since I have no life, I went and counted how many of those images are polar bear or sort of polar bear related. It's about a third when I did this thing, a quarter to a third. So the thing is, let's say you're basically, Joe the average citizen. It's like, hey, I took out my recycling on Wednesday. I separated the papers from the cans. I gave $25 to the Nature Conservancy. I like the museum. This is really cool stuff. I kind of did my part. What else do you want me to do? And that's, so I would say that this is, frankly, it's a much more important issue than just an environmental issue. It's about water. My second point is really all about the water. Too much, too little, wrong place, wrong time. Salty where it used to be fresh if you're down near the sea level. Liquid where it used to be solid if you're anywhere up in the Arctic or on a glacier or near some of the ice sheets. More acidic. That's just sort of like the silent evil twin of climate change. Is the fact that, you put all this CO2 in the atmosphere, about half of it, almost half of it, actually gets absorbed, sucked up. If I say sucked up, all the engineers and chemical engineers will just like throw stuff at me. Sucked up by the ocean. Too bad, people understand sucked up, right? Okay, I know it's not the chemical reaction, but people get it. It gets taken up by the seawater. long story short, it's the Larsen and then a miracle occurs in step 2, you end up with a more acidic ocean. Now, it's not like you stick your finger in and you just have bone left, but it's a bigger change in the chemistry of the ocean in a century than we had seen in the past several 100,000 years. So the ecosystems, how are the critters going to deal with it? And I'll talk about that a little bit later. So, if you had to sort of pick one unifying theory, and I could argue you could pick some others. I picked water. Who remembers these guys down here? This is a blast from the 90s here. Clinton, of course. Who's the other guy? Carville, right. And Carville said famously, it's the economy stupid, right? Yeah, okay. Well, I would say it's the change, not stupid, but it's the change part of climate change is frankly scary to me. I mean, is it pretty hot here in the summer? Yeah. Is it cold here in the winter? Yeah. I was at Yellowstone a week after it was minus 40 this winter. It was pretty cold. Is that optimum? I don't know. I mean, San Diego to me is pretty much optimum. North coast of Italy is not bad either. That's optimum. But the thing we've had for several thousand years is stability. We kind of know about how cold is cold, about how hot is hot, about how much rain you're going to get, about when it's going to fall. And we know that. That's how we developed our civilization. So now it's like, hey, guess what? We're going to change it and see what happens. So that's why, while there will be some winners and some benefits, a lot of stuff is not because we've tuned our system so that it would work with the climate we had, not necessarily the climate we're going to get. So I'm just going to go through this a little bit because I get asked or told, depending on how nice the person is, hey, Titley, don't you know that the climate's always changed and it's going to always change again? Yes, it is. So this is a graph that, this is like really old over here. This is almost 500,000 years old, and going that way is the present. So carbon dioxide, temperature, sea level. Sea level, oh, by the way, in hundreds of feet. Everybody kind of freaks out about, 2 or 3 feet. Hundreds of feet, up and down, big time up and down. And you can see the CO2 goes up and down, pretty well correlated. Not perfectly, but pretty well correlated. So has the climate always changed in the past, way, way, way before people? Yes. Will it change in the long-term geologic future, hundreds of thousands of years? Yes. But I'm not going to be around hundreds of thousands of years from now. Neither will my children or even my grandchildren, especially since I don't have any. But you guys probably do. So, we don't really, with all due respect to the paleo guys and gals, it's good. I need to know that. But it's all about me, right? It's people, not polar bears and not geologists. It's people. So when I look and I blow up that piece right at the end, so now I'm starting 24,000 years ago, and I'm going to the present, what did we get? This is sea level, and it's coming out of the ice age, and then we get stability. And it's like somebody almost flipped a switch off on the climate variability. When did we get agriculture? When did we get like pyramids and stuff like that? Think back to the start of the Big Bang Theory, right? It's all in there. It started about, that 10,000 years ago. So we literally built civilization, human civilization, based on this. So this stability to me, if I had to pick the one thing that's like scary, it's like kind of losing the stability. So that's what we've got. So there's this guy, I'm like, if I wasn't doing this stuff, maybe I'd be a history major and like living in my mom's garage or something like that. Sorry, any history majors. But I'm sorry, I like history. So I read World War I read a bunch of stuff. So there's this guy, Clemenceau, a French general. He became the premier of France in World War I. And he famously said that war is too important to be left to the generals. I would argue with climate change, it's frankly too important to be treated as a niche group. It's too important. Okay, so what did I say? I had people, water, change. If you guys remember that, I am thrilled. Go drink now. I'm that people, water, change. And that's kind of what climate change is about. Okay, for the over 30-something, 40-something crowd, anyone have any idea what this thing is? Sextant, yeah. Why do I have, okay, he's lost it again. Why does he have this in a climate change talk? I've got this here because one of my first jobs in the Navy, frankly, it was one of the best ones I ever had, was I got to be navigator on a guided missile destroyer. It is a cool job. You're the only person that gets to tell the captain where to go. It's pretty cool. And this was, I know there's about half the audience that won't even know there was such a time, but there was a time before global positioning system. You did not just pull this thing out, and it did not tell you to within 50 meters of where you are on the world. You actually had to shoot the stars. It was kind of cool. I like doing that stuff. And one of the things I learned as navigator, especially if you don't want to find yourself working at Walmart the next day, is use all the information. Don't trust 100% any one thing. So use everything, look at everything, use this stuff in between your ears to kind of like process it and assess it. Don't trust anything 100%. And so when Admiral Ruffhead asked me to like kind of look at this, I mean, I got to admit, I was kind of on the skeptical side of this whole thing. As I said, I grew up as a meteorologist, not as a climatologist. I grew up sort of living and dying by the computer models, and I'll tell you, for a weather model, nowadays, you're pretty good out to 2 days, 3 days, 5, a little, whatever. 7, you're really taking your chances, and by 10, it's like, just look at climatology, because you're not going to get there. When I was doing this stuff at Penn State, you could get out to about a day and a half, and after that, it's like, take the thing, and you could do that with it. So I didn't want to trust any one thing. So I wanted to look at everything. And the first thing I'll tell you I looked at was, well, geez, if the sun's increasing, it's going to get warmer. Duh. That to me didn't seem like a real scientific breakthrough. So I went and found actually a lady named Dr. Judith Lean, and she turned out to be one of like NASA's best solar physicists. So it's like, hey, Judy. So I invited her over to the Naval Observatory. We had lunch. And it's like, hey, what can you tell me? So she told me lots of cool stuff, but here's kind of in one graph what she told me. So the blue is the sun, and the red is the temperature from, late 19th century to now. And you can kind of see that these two sort of split apart about 30 years ago. The sun, if anything, is actually down a little bit. I mean, I'm not going to get too excited about little wiggles and wobbles, but if anything, the sun might be down a tad. The temperatures keep on going up. So it's like, well, maybe it's not the sun. And yeah, you got, and why do I have these things averaged over 11 years? Because there's a 11-year solar cycle, right? So you want to take out that wibble and wobble, So I average the temperatures and I average the sun, and this is kind of what you get. So it's like, well, maybe that's not it. So then, you go talk to a lot of folks, and a lot of folks will tell you, hey, the Earth's temperatures have not warmed the air temperatures, since pick a date, 1998, pick a date. And it turns out, all these blue lines, this goes back to like the 70s and to now, for any of those blue lines at the starting and ending point, I could say that the Earth is basically either not warmed. Let's see if I can make this thing work. I'm going to screw it up, so I'm going to put it down. It'd be better if I put it down. No, I think I got it. Yeah, we'll put it down. You don't want me touching this stuff. So for these blue lines, you can easily find 5, 7, 8, 12-year periods where basically there's been a whole lot of noise, ups and downs, big year-to-year variability. That ain't going away anytime soon, folks, I'll tell you. And you could say, hey, from here to here, there's no warming. What are you guys talking about? Here to here, no warming. It's sort of like an escalator. But then you step back and you sort of look at, okay, what's the big trend? The big trend is the red line. And, you can kind of say, when you look at this, so this whole climate thing, I admit, it's a little abstract, but you're looking at big time and you're looking at big space. So this is global, and this is over decades. You can see the trend. It probably shows up a little bit easier. In this graph, it came from the World Meteorological Organization. Again, just took all the global temperatures and I didn't try to arbitrarily show one thing or another. It's like, hey, Happy New Year at the beginning of 1901, 1911, etc. And this is what you get. So when you hear, hey, there's really no warming, that's just kind of like what it is. So, okay, that's sort of interesting. So let me show you something else. Here's NASA temperatures, global temperatures from the late 19th century to basically now, to 2012. And this is a difference. It's basically you take the middle part of the century and you call it 0. So blue is colder, red is going to be warmer. And I'll just run this loop once or maybe twice. And the year is just to the left of the scale. So 1892, you see that? Okay, 1900, happy centennial. Okay, World War I coming up. 1914, roaring 20s. Watch the Dust Bowl. 30, 31, 33. Big splotch over the U.S., but not necessarily over every place else. There's still a lot of blues. 50s, whole lot of particulates. Everybody's factories are like working overtime here, trying to recover from World War II. 80s, no, not yet. 70s, sorry. How can I miss a disco era? 80s, Reagan. Okay, tear down that wall. It's gone. Okay, 90s. I did not know. Okay, Bush 43. Here we are. So that's kind of the global. I'll run it one more time. I'll just run it one more time. So are there computers involved with this? Is this a forecast? This is just what's happening. So again, don't trust anything 100%. Look at a lot of different stuff. So again, 1915. You guys, can you see that? Can you see the dates? Okay, then I'll shut up because there's nothing worse than somebody reading something to you on the slide that you can see. The Dust Bowl to me is cool because you can see how, although it was pretty warm in the U.S., it wasn't really that much of a global thing. 70s almost got cool coming up here. A lot of blues still. And here we go in the 80s, and this is where you sort of get on that escalator. 90s, 2000. So those are just observations. That's what we have. Okay. All right. You're bored of temperatures, so am I. So we'll talk about rainfall. Again, from my friend Jerry Hatfield, Dr. Jerry Hatfield, he gave me the pictures on the right and left. The graphs come out of that National Climatic Assessment. Again, you can dig through all 1,100 pages and find these yourselves. But really, one of the things we see with climate change, it was kind of predicted, and now we're seeing it again. These are observations. These are not predictions. It's like when it rains or snows, it rains harder, and you get a whole lot more really fast, sort of intensity. You see it more in the Northeast, actually, than any place else. It's up by 71%. You know, the way the report split out, kind of all the way from Texas to Montana, it's a big chunk of place. There may be variations in there. I don't know. Comes out at about 16%. So some of that. So these pictures on the top left and bottom right there are just some pictures Jerry gave me of fields after these real big inundations. You either get the water in the fields or even, can get some big time erosion. So that's another piece of evidence that we're seeing changes in this precipitation pattern. And unfortunately, that's very consistent with what the climate scientists thought we would see with global warming. So here's another one, and this is kind of one that you may not think of all the time in Montana, but this is the ocean. So I'm an oceanographer as well, sort of a closet oceanographer as well as a recovering forecaster. And what this shows, the red is how much heat is in the atmosphere, in the land. The blue, whether it's light blue is shallow and dark blue is deeper water, that's where the heat is. So it's kind of like, who sort of Willie Sutton, the Willie Sutton theory, why did he rob banks? That's where the money was. So I tell young scientists when they want to do climate stuff, what to do? Go study the ocean. That's where the heat is. About 90%, give or take, of the heat is in the ocean. So you can think of the ocean as a dog, and the atmosphere is the tail. We sort of get wagged around. It's one of the reasons you get so much year-to-year variability. So I've sometimes been asked, especially when I was in the Navy, it's like, Titley, did you like get religion? Do you believe in climate science? And I tell them, no, I don't believe in climate science. I might go to the Church of the Radiative Transfer Equation, but I don't believe in climate. I'm convinced by the evidence. And that's all it is. I mean, belief is like what you do with you and your being or your God on Sundays or Saturdays or Fridays. That's belief. This is just like, hey, what did the data tell me? And that's kind of what, when I looked at this stuff, as I said, I wasn't too sure about it. I looked at this stuff, and it's like, you know, there's a lot here. And not only is it a lot here, as you look at it more, not only is it science, they find out that it was actually cutting-edge 19th century science. Fourier, a French guy, Tyndall, who is a Scot, and Arnhus, who's a Swede. Basically, Fourier figured out that without the gases in the atmosphere, we'd have a different temperature, and so on, until you get to Arnhus, who actually said, hey, this Industrial Revolution thing, we're putting a lot more greenhouse gases in, we're going to change the temperatures. And he actually did, by paper and pencil, the first greenhouse gas climate change calculations. Turned out he grossly underestimated this. But I kind of like this. You got a French, a Scot, a Swede. They go into the climate bar, whatever. I don't know. So, you know, whatever. Something. I'm sure there's something there. It's probably inappropriate, so I won't go any further. But these guys have figured it out. So, I mean, I love it when I hear, oh, we don't know the science and all this kind of stuff. We know tons. We don't know the details. We don't know the details when somebody says, well, tell me what Bozeman climate's going to be like in the year, you know, March of 2055. I don't know. You know, I can give you some ranges, but we don't know those details. And there are, and I'll show you at the later on here, there are things that we've got to still figure out. But big flick, we know this stuff. It's 19th century stuff. I'll tell you, if the intelligence community could tell the like the president and the national security staff and the CIA as much as the climate community can say about what the world's going to be like in 30 years from now, we'd give them all medals of freedom. Okay? And we spend a whole lot more on the intel guys than we do on the climate guys. And rightfully so. It's a whole lot harder problem. You got people, they're trying to deceive you, da-da-da. So that's that. Okay, here's my one and only climate model. And it is hardly a cutting-edge model. It actually was published back in 1980 in a journal called Nature, which is a pretty good science journal. And it was by a guy named Jim Hansen, the science guy, not the Muppets guy. And what he did, you know, oh, by the way, if this looks like a Xerox of a Xerox of a PDF of a Xerox, it's because it is, because it was 1980. He worked using cutting-edge 1980 technology to come up with, hey, you know, these black lines are kind of where we're going to go. He knew where we had been in the 60s and 70s. And he had to make some assumptions about greenhouse gases, blah, blah, blah. Well, the red lines are the annual temperatures, and then that big, that looks like somebody took a felt-tip purple line, that's like a 5-year average. So you can see that Hansen had a pretty good idea, but he was actually, he undershot. So there's a saying, at least in climate and meteorology, and probably a lot of other fields too, that all models are wrong, but some are useful. I would argue that this was useful because it said, hey guys, we're going to get on an escalator pretty soon and we're going to start going up. It was wrong because he was actually under forecasting. And of course, you can find models that were too aggressive or over forecasting. But again, you know, since we kind of know the basics, we can kind of figure this stuff out. Anybody wonder why I can't do weather forecast more than 5 days, but I can stand up here and, you know, I'm talking to you about 30-year stuff out? Is that, like, anybody kind of like, why is that? Maybe, maybe not, or, oh my God, he's going to keep talking. Okay, but I'll tell you anyways. So really what it is like if you're going to do weather for Montana, you know, it was a gorgeous day here in Bozeman, what did you need to know? If you're going to get an accurate forecast, you'd really needed to know, like, what was it like over Idaho and Washington and Alberta and British Columbia yesterday? Is that weather kind of moving from the north and moving from the west? That's what you had to know. It's for anybody here in the science and engineering fields, it's the initial conditions. But you have to kind of know the starting weather, you know, as it moves over you. And as you can imagine, you know, the further you go out in time, the less you can figure out, well, geez, what was the weather over Japan? And it's changed so much by the time it gets here, it's like, you're totally wrong in 5 or 7 days. Climate could care less. I could start a climate model with it being 50 and rainy in Bozeman today, and it would still give me the same answer it would have if I'd started it being sunny and 85. Climate's all about how much energy you're putting into the system, how is the Earth turning relative to the sun, how do the gases trap or release the heat, what's the ocean doing with that heat. Again, in technical terms, it's called boundary conditions, but that's why we can, in the big picture, have some faith in climate models. They're useful. They're wrong, but they're useful. Whereas, you know, if I was trying to sell you a weather prediction for like a month or 6 months or 12 months, down to the partly cloudy, rain in the afternoon, you guys should just like leave now if I was doing that. Okay. So who's heard also every time we get a really big event, you hear in the media, it was caused by climate. And then, no, it wasn't. Yes, it was. No, it wasn't. It sounds to me like a bunch of second graders right at lunchtime recess, and they're all doing this, and it's like, dudes, just like stop. So I kind of look at this a little bit different. I look at this as sort of like more like odds. So imagine, you've got casinos. There's a casino in my hotel. That's kind of cool. They gave me $5. I would lose that and everything else, so I'm not going to play, but it's kind of cool. Let's say Sandy, Hurricane Sandy, top left picture. Let's say, like, if you were playing poker, that would be analogous to having a full house with aces high, okay? So it's not like you get it every day, but, but it's not impossible. And when I gave this talk in Utah, I first had to tell them, okay, let's get in a bus, go to the Nevada state line, and then I could talk about this. Then it was okay. They were good with that. The Mormons liked it. So, okay, full house, aces high. So how often do you get that? Well, imagine your card deck kind of looks like that. Again, be careful going to Vegas with that card deck. So what I think of is like weather, what we live in. Weather is that hand that you're holding in your hand. Those 5 cards you got in your hand, that's weather. That's what you're living with. That's what you got to play, good or bad, nice or not so nice today. Climate is the card deck from where that came from. And I would argue that climate change, we're probably putting an extra ace or 2 into that card deck. And that's kind of, rather than the yes it is, no it isn't kind of thing, that's kind of how I think about it. Hopefully that makes some sense. Okay, I'm going to switch gears just a little bit. I'm going to talk about the Arctic, sea level rise, and then some more general security issues, and then we're going to wrap up. So that's what's coming up. Okay, so Arctic, this is what got me into this whole thing. Why? Because my boss was interested, and when your boss in the Navy is interested, that makes you fascinated. Not just interested, but fascinated. I was fascinated. So, okay, and by now you guys know that I can only remember 3 things, because after that it gets too hard. So climate change, people, water, change. The Arctic, it's an ocean. It is changing faster than any place else in the world physically, and it is not a vacuum. So unlike Vegas, what happens in the Arctic does not stay in the Arctic. And that's true politically, economically. It's also true on the physical science. So, we're not going to spend a whole lot of time on that, but this is changing faster. So I'll show you one thing, but I got to show you just one thing. If I could make this pointer work, but I'll probably black out the screen. Ooh. Okay, so anyone have any idea what those 2 islands are? The Diomede Islands. This is Little Diomede, Big Diomede. You know who owns Little Diomede? The U.S. Who owns Big Diomede? Russia. So, on a clear day, you can stand here on the west part of Little Diomede and look across about 2,000 yards of water, and you can see Russia from Alaska. I'll bet you didn't know you were going to learn that in a climate talk. Okay, so here's another observations, and I'll let this run a few times. This is from my friends at NOAA. This is Arctic sea ice. These are observations. There's actually a bunch of polar orbiting radar satellites. They look through the clouds, and they can tell not only how much ice there is, so if you see some sort of blue, you got ice, but where the thick ice is. And the thick ice shows up as white. Whiter is thicker, it's harder, it's multi-year. Not so long ago, the Arctic used to be totally this really thick ice. It melted back a little in the summer, came back a little bit in the winter, and that's all it did. It's just sort of vibrated. Think of like your high school chemistry, somebody shows you the vibrating molecule. That's what it was. Watch what happens. 05, 06, watch 07. Boom. Where'd the ice go? Does it come back? It tries. 10, 11, boom. That, ladies and gents, is a bigger change than you or I will probably ever see physically in our lives on anything. So people, when I started this even, said, well, this may change. It'll take decades, maybe centuries. So we've seen this inside of 10 years. I'll just run it this one more time. 05, 06, 07. Massive security implications for the Arctic opening up. It opens up trade routes, it opens up economies. Russia has traditionally used that northern border, the ice here, as basically its protection. Russia's not, sometimes you could say Russia's a little bit of a paranoid nation. So how, as that opens up, how's that going to impact them? You got, 1 billion people in China that are sort of now looking at all that depopulated land in Siberia. It's kind of interesting. You got all kinds of resources. And as I said, you're starting to look at potential of trade routes. So we've all heard of the Northwest Passage. Don't worry about it. Why do I say that? It's shallow, it's hard, it's like Route 66. Mythical, really cool, sounds cool, not going to be a lot of traffic. Here's Interstate 40. Boring, but this is where the traffic goes. So you got one going by Russia. They call it the Northern Sea Route. Oh, by the way, they charge a lot for you to use it. We think, I shouldn't say we, I should say the U.S. Navy, they updated the roadmap that I did in 2009, so this just came out a couple months ago. They think in maybe a couple decades, seasonally, you'll have what I call the over-the-top route. Just start off at the Bering Strait, up at the top, and end up down at Iceland. Oh, by the way, Iceland is building big-time port facilities. You know who has the biggest embassy in Iceland? China. That's interesting. You know who's really been looking at Greenland? China. Why? 50,000 native people, Greenland wants to be independent. That could be like Kuwait of the North. That could be interesting. So for all the political scientists and international relations folks, there's some things to think about. Okay, I could talk all night about the Arctic, but I like you guys, so I won't. We'll move on to sea level. Okay, sea level, I got these two guys up here, Reagan and O'Neill. And of course, O'Neill, Speaker of the House, he very famously said, all politics is local, right? So that's whenever anybody talks to you about sea level rise is local too. There's the big global component, but there also turns out if the currents change, that changes, and the land itself is going up and down. Here in Montana, I'm not going to spend a whole lot of time on sea level. It's like, dude, don't you know we're at 5,200 feet? So yes, I do. But I'll show you some places that do care. Bangladesh, yeah, they kind of care. Tuvalu, they were the rock stars of Copenhagen about 5 years ago. I went to their booth in the next year. There was nobody there. It was really sad. I don't think they went underwater, though, not yet. But here's from a defense perspective, we care about this kind of like, why is he showing this? Diego Garcia. If anybody's been in the military in the last 25 or 30 years, you've probably heard of Diego Garcia. Department of Defense has used this. It's actually a British island. The Brits let us do whatever we like as long as we're nice to their sea turtles. I'm serious, actually. They're pretty serious about their environmental stuff over there. And it's a massive staging base for all kinds of stuff. I'll just leave it at that. It's also only about 2 meters above the sea. So if we lose this, because the seas come up, that becomes a really, really big deal. It's a domestic issue as well. These are the number of people, almost 4 million people that live within, 3 feet or so of high tide. How many of those are in Montana? Oh, 0. That's okay, good. But when I go down to Fort Lauderdale, they kind of key in on this slide for some reason. I don't know why. If you've ever been down to Miami, down to Fort Lauderdale, Tampa, when you fly, get a window seat when you fly out of there. And, United willing, and it's a nice day and everything. Look down. Man, it looks like the sea's right there already. It kind of is. So, these guys got a real issue. Oh, by the way, it's limestone. Who's the geologist in here, right? What happens with limestone? Build the biggest wall you want. The water goes under it. So, we say, we should be like the Dutch. Well, you can be like the Dutch all you want. It ain't going to help you down here. So that's an issue. We've seen what happens around with Sandy. Norfolk, huge issue, big defense thing, so big security issue. Sacramento Delta, maybe because you're further west, you're a little more attuned to that. When I talk about that to people in East, it's like, dude, what are you talking about? But there's a real issue around Sacramento and the levee system out there. It's probably not in much better shape than it was around New Orleans pre-Katrina. So I've talked about some of this already. Picture of pretty fishes. This is not my polar bear slide. But this is really that whole ecosystem and how it's going to respond to the change in chemistry. And the reason I care is because of that food security, that second slide I showed, because about 2 billion plus or minus people get their protein from the ocean. So we've already shown how many more calories we have to grow on the land. Now, if you got 2 more billion people who can't get what they used to get out of the ocean because we've screwed up that ecosystem because of the carbon dioxide and the chemical reactions, think they're going to be happy? Probably not. Unhappy people tends to be a security issue. Okay, so just again, change in fish catch, red is bad. Those tropical islands, a lot of places in the Pacific where a lot of people live, it's not good. Okay, drought. In general, you look at this and you say, well, geez, Mideast, not so good. Spain, Southern Europe, not so good. Some parts of Southern China, not so good. The West, and at first you look at this and you say, Montana, kind of right on that border, like Pennsylvania, like I look at this. In very general terms, what I think of, this is like caveman simple climate stuff, wetter in the north, like north of 45 or 50, drier in the subtropics, and then right on the equator itself, probably wetter again. That's in gross terms kind of how it's going to play out there. And you can kind of see this. But be careful, taking one of these maps, and it's pretty pictures and stuff, and thinking, okay, I know exactly what I have. Again, look at everything. So here's actual real data, which I like. Observations, again, the Palmer Drought Index, and this is for the northern plains, kind of like here. It's actually, not so bad. Certainly we've had droughts, and we will continue to, but not so bad. So I would say the jury is out on how our precipitation is going to change. I would not come to Montana and say, oh, dudes, it's just going to totally dry out here. I don't think the data support that. But how that water and snow falls, that may change. But this is, we're right on the edge here between drier certainly to the south, wetter certainly to the north, to be determined how it plays out here. Food security. We talked about this with the Mideast students. You look at this big change in wheat prices. One of the reasons that wheat price almost doubled and pretty quickly was because of the fires and the droughts in Russia and Ukraine, as well as Australia, some in China. Again, wheat, sort of like some oil, is kind of this global market. Fast rising price puts on pressure. And then if you add that to internal tensions, bad governance, other grievances, it's sort of like just throwing matches, but rather than throwing matches into a nice wet sandpit, you're throwing matches into tinder that's being sprinkled with kerosene. One of them catches, and boom, you're off to the races. And now we've sort of seen the same thing in Syria with the drought as one of the underlying factors. Not that climate change caused that, but an underlying factor. We ignore it long enough, well, now we got a problem in Iraq. So, these things aren't getting better with time. So a lot of reports have been put out, and again, this is a report that I was part of, something accelerating risks to climate change, put out about 2 weeks ago. You can read this is only 48 pages, way better than those 1,100 ones. Or you can see my Wordle diagram, but you can, and this is it. So you can see the words that we've had, but we've talked about food and water and the Arctic and the infrastructure, the energy, and how all these things put together. And our assessment, and this was 16 3- and 4-star admirals and generals, plus me. I think they needed somebody to get coffee for the 3 and 4 stars. But this idea that the risks are accelerating. We've seen ISIS, we've seen what's going on in the Mideast, and it's a catalyst for conflict. So, that's on the security side. Let me talk about food security just a little bit. And again, my friend Jerry Hatfield helped me with some of these things. Pretty simple. Here are the inputs. You guys know this. Anybody who's in the agriculture business, you guys know this better than I do. But also the indirect stuff. So the talk after me at the Field and Weed Day was all about the weeds. I understood about 10% of it, but it sounded pretty cool and it sounded very important. So how this race between the stuff we want to grow and the stuff we don't want to grow, and how that's gonna come out. I'll just go through these very, very quickly. I'm not going to read them to you. I know you can all do that. But I've tried to highlight, and again, these are Jerry's assessments of the National Climatic Assessment and how this plays out into agriculture. We can talk about it. You may agree, you may disagree with this, but this is kind of what USDA, the smart people in the research arm of USDA are seeing. And I got 2 more slides. I'll just let you let you read that there. And again, in the Q&A, I mean, I'd be interested in your assessment. It's like, yeah, this is kind of what we're seeing, or hey, it may be happening, but this is not what we're seeing in Montana. It's not what we're seeing in this part. And I'd just be interested in your guys' thoughts on this if you're in the agriculture enterprise. You know, kind of, I'd say this is almost sort of the bottom line is, you know, the enterprise has been able to adapt, but, you know, we've only, sort of like that song, we've only just begun, so we're going to have to keep going there on that. Okay, so what are we going to do? You know, traditionally we look backwards. You know, if you're going to build a bridge, if you're going to build a sewer system, you look backwards 100 years. If you're a good engineer, you add 10 or 15%, right? Okay, and then you go build it. You know, but now, looking backwards may not be enough. I would argue that we need to look forwards into that sort of misty, distant future. You know, it's not a perfect crystal ball, but we got to take what we know, apply risk management, and go for that. So when I say risk management, you know, here's kind of just I'll just build this slide, but a fairly simple way you can do this. You know, you take the projections, they've got uncertainties, you figure out what's likely, what's dangerous. These are like exceedance probabilities, if you've worked with that. Do something, and then see how it works. Simple, right? One slide, I fixed that. Yeah, if only it was that easy. But there are methods to deal with this stuff, and this actually kind of works. You know, something the agriculture department is doing is there's something called regional climate hubs. I don't know if anybody's heard of them or not. They really just started up. I think they're about 2 months old. So when I've gone to the website for the Northern Plains one, it is in Fort Collins, Colorado State. There's a couple pages up right now, but you know, again, if I was certainly in the agriculture enterprise or research business and up here, I'd keep my eye on those guys and see if they're meeting your needs. Are they doing what you would like them to? And if they're not, ask them to. Ask them how you can become involved. Okay, I think there's some good news on this whole climate thing. And this is, maybe it's kind of a bizarre graphic, blame me if it is. I see a lot of, I'll call them vectors, different businesses and aspects kind of pushing now kind of to get to the same thing. I've been fortunate enough to be invited to a few faith-based groups. The Vatican is doing some stuff. So this guy, the Pope here, he's now getting involved in this stuff. I was out for Council of Environment and Jewish Life, COJL. They invited me to come and talk about climate change. So I'm seeing this becoming a faith issue in at least some components of faiths. On the right-hand side at like the 1 o'clock, 2 o'clock position, the whole idea of the insurance guys. Insurance guys are about money. They're about future risk. Lloyd's of London about 4 weeks ago said, you know, guys, in their industry, if you're not thinking about climate, then you're probably missing the boat and you're putting your company at risk. This whole idea of divesting educational endowment funds. It started at Harvard. Stanford has basically divested of coal from their endowment. You know, people say, well, that doesn't matter and stuff, but you know, that's what we said about South Africa too, and it got changes. And money talks. Let's not kid ourselves. Money talks. The health guys. I've talked about security. Some media stuff. There's a guy named James Baylock. He made this incredible film called Chasing Ice. If you ever have a chance to see it, it is like totally cool. I mean, I just go watch it for that. You know, I do have a polar bear, and that's my hat tip to the environmentalists that have really for decades talked about this issue. They're still there. The business risk guys, especially post-financial Great Recession, you know, if you're a corporate director and if there is a risk identified, you better have a mitigation plan, because if you don't, you're now liable. So it's like, oh, shoot, climate, it's a risk, huh? What am I doing? So there's all these things pushing. It's not going to be a straight line. This guy, Dan Kahan on the left, Daniel Kahneman on the right, they talk a lot about how these messages are received, and it's not some nice straight line. There's a lot of physical scientists that think if you just talk about the facts, and especially if you talk louder, you know, or if you tell them 97% of people agree with this, oh, that'll make everybody agree. It doesn't. It really doesn't. You know, you need to you identify with people who are kind of like you, know, and if you're going to wander off that nice comfort zone, you gotta, it's like, my God, I'm alienating all my friends and the people I like and I work with, and that's very, very hard to do. So it's sort of easier, even if you're personally not quite sure, it's like there might be something here, but I'm not going to open my mouth. So there's a lot of that going on. Kahneman talks about how we sort of put all this stuff together. Fascinating book, and it works for both weather warnings and risk and climate. We don't have time right now to go through that, but if you're interested in that stuff, this book, Thinking Fast and Slow, is very, very good for that. There are surprises still to come. We still need to do better, we being the climate community, need to do better at really understanding the interactions between the ocean, the deep ocean, and the shallow ocean to the land. Aerosols are still being figured out. The whole Arctic amplification, this is a picture of Jennifer Francis, Dr. Francis. She works out of Rutgers and got a lot of media attention a few months ago for saying, you know, hey, this weird weather is because the ice is melting. That's actually it's quite controversial in the meteorology community, but it's controversial in a very good sense. People go and they go do research and observations and modeling studies, and there's a very active debate in the professional community. That's what science is supposed to do, and we'll eventually figure it out. It will not be a straight line, but we'll figure it out. That kind of weird graphic down at the bottom left, you know, geoengineering. Anybody heard of geoengineering? This is the intentional modification, large-scale intentional modification of climate to undo the unintentional large-scale modification of climate. What could possibly go wrong, right? Piece of cake. What could go wrong? Watch this. So, full disclosure, I'm on a National Academies committee that is looking at this, a technical evaluation. We hope to have our report out probably by about the middle of fall, and we'll have some thoughts on this. This guy here, Niels Bohr, anyone know? Why do I have him up there? I've got him up there because he rather famously said that predictions are tough, especially when they're about the future. So, you know, when anybody tells you they know what the future is going to be, my recommendation is first put your hand on your wallet, and second, you know, back away slowly, sort of like the bears. I don't know if you need bear spray or not, but you know, and I don't claim that my predictions or projections are any better. But I think we can use science to sort of bound these things and then use risk management techniques to figure out where are the smart places to put our finite dollars. Okay, this came out of a National Academy study quite recently, I think Christmas time. There are some decreasing threats. If you remember, maybe a decade ago, there was this movie, The Day After Tomorrow. I never watched it. I just can't watch it. But, you know, shutting down the Gulf Stream, you know, New York City freezes over, Europe freezes over, blah, blah, blah. There was actually some stuff around the early 2000s that people really thought the Gulf Stream was going to shut down. Probably not. Sudden release of Arctic methane in this century, probably not. The Greenland ice sheet, it's probably not going to just collapse. But there are risks. This West Antarctic ice sheet, and now we've seen since this report came out that it looks like it's really on the move, and over a couple of centuries, that could be 5, 6, 7, 8, 9, 10 feet of sea level rise. It'll take a few hundred years, but it looks like it's going. How sensitive is the climate? We still don't exactly know. The whole extreme weather thing. And this report said, you know, that geoengineering thing may not fix it after all. You may just simply change the climate again. Okay, so here's that variability thing. You know, he was like, you know, I was on about this variability thing at the beginning, and I'm going to sort of close with it again, because I think it's important. So really old over here, 60,000 years. Here's, you know, today. There's this book by Nicholas Wade called Before the Dawn. So if anybody here is interested in, like, paleogenetics, this is your guy. Now, if you're not, you might want to pass on it. But basically, the bottom line of what he says is, hey, by about 50,000 years ago, we, all us humans, got the brains we have today about 50,000 years ago. You know, so it's like, okay, we got our brains. You know, theoretically, if you taught them English or whatever, you know, you could go have a conversation and, you know, it'd be great, derive partial differential equations, whatever you want to do with them, you know, 50,000 years ago. But we didn't, you know, we didn't get to the agriculture, pyramids, et cetera, till then. And, you know, so my question is, why didn't we have one of these things 30,000 years ago? Well, I would argue, you know, we're dealing with this. What's this? This isn't the average climate. This is how much it's changing, okay? A lot, not much. And look at what happened about 10,000 years ago. To me, it looks like somebody just took a light switch and turned it off. So yeah, there's like little ice ages and warm periods and stuff, but compared to what we know the climate can change like, it's tiny. It's tiny. So the big question is are we going to push ourselves for different reasons? This was ice age stuff. but for different reasons, are we going to push ourselves? Oh, that was the button I wasn't supposed to touch. Not that one either. I'm screwed. Okay. Let's see here. Help me. Okay. This is the don't touch it button. Okay. Somebody help, please. Let's see. So we're on slide 45. And how do I get it back? There we go. Yeah, right. Okay. How many PhDs does it take to change this? Okay. So that's kind of, so I talked about people, water change. Hopefully you guys can remember that. This is this whole change thing. This is, if there's something that scares me about climate change, it's kind of this thing. It's how do we deal with this? So, here's it's not the, most optimistic thing, but, history is a race between education and catastrophe. So we're at a university, right? So hopefully the education wins. Okay, so I've talked about all this kind of global stuff, big flick, all that. I'm just going to try to make it maybe a tad more personal as we wrap up here. So I mentioned at the very beginning that some of my jobs were working naval meteorology and oceanography, and our headquarters is actually down at a place called Stennis Space Center. It's a NASA base. It's right on the Mississippi-Louisiana border, right on the Gulf Coast, on the Pearl River. There's a variety of reasons, doesn't matter what. That's where we were. This is the house we lived in, a little tiny place called Waveland, Mississippi. And that was my house. We were up, we met all the FEMA guidelines, all that kind of stuff, because the ocean's only about 200 meters to the left of that picture there. And this is what it looked like when I came back after Katrina. And that's me, kind of figuring out, okay, so what's next here? So when we say we lost our house, we really did, because nobody had cleaned up. I mean, we really don't know where, to this day, we don't know where our house went. It ain't here. You can all see that. It's not here. It was pretty well cleaned up. And every single house on the block looked just like this. See, if you ever want to know what a 9-meter storm surge does, this is a pretty good indication of what 9-meter storm surge will do. Now, the good thing is the ugliest house on the whole block was like one up. So the water was on the left, came up the street to the right here. So what I really hope is my house came off the foundations, and its last final act of defiance was it knocked down this ugly house and cleaned up the neighborhood. I don't know, but that's what I tell myself. But I point this up, not for sympathy points or anything, but because this stuff really is about people. Okay, these storm surges, these rising sea levels and stuff, it affects us. It's going to affect rich people, middle-class people, poor people. Oh, by the way, it's going to affect a whole lot more poor people than me. If I look at, the people who are affected by this stuff, I'm like in the, 2% or whatever. I had insurance, we have resources, I had a job. It still sucked, but it was a whole lot easier for me than for many, many, many other people who get affected by these kind of things. They have nothing. So this stuff is serious, and I point that out. But I'll end with this guy, or Churchill. And Churchill very famously said that Americans can always be counted upon to do the right thing after exhausting every other possibility. So I would argue we might still be in that process of exhausting possibilities right now. And I have also been, sometimes people say, well, Titley, geez, you're an American, you served in the Navy, you got to end with a Brit, really? So it's like, okay, so I'll end with this guy. John Wayne, he said, hey, life is tough, but it's tougher if you're stupid. So don't be stupid, don't be stupid. It's not that hard. So, but but I like these guys. I mean, America, we talked a little bit, just very briefly, about belief. Do I believe in climate change? No, I'm convinced by the evidence. It's up to each one of us what, if any, kind of religions we believe in and other belief things. One thing I believe in is I believe in America. I believe that this is a country that, when focused, does absolutely amazing, incredible things. And I think the rest of the world, or even Americans themselves, would be very, very short-sighted to bet against us. We can do amazing things. We still can, and we will. We got to be focused. So, this whole Apollo, this came out of, the Apollo 13. The more you read about that, those guys should have died. There is no way in God's green earth that we should have got those guys home. We did. We did because we were focused. We put some of the most amazing ingenuity and courage and persistence in, and we will do that for climate. We will. We will fix this. We will figure this stuff out. We will probably go through a bunch of pain and suffering, and we will wish we had started 15, 20, 30 years earlier, but you can't get that back. So don't worry about that too much. Worry about what we're going to do forward. But we will fix this. So with that, ladies and gents, you have been wonderful and very patient. Thank you very much. That's my campus at Penn State, and that was us when we went up to the Arctic, which was really cool. So we flew, we get in a plane, we get to Barrow or Prudhoe Bay, we get in this little thing, we land on the ice, we get in a helicopter, we come up to where the submarine's going to be, and all you see is white, just white. So I've got the Lieutenant Governor of Alaska with me and the head of the Coast Guard Alaska District, a guy named Chris Colvin. And, so there's a guy, of course, with a safety brief, because we're the Navy, you got to have a safety brief. He says, okay, well, the submarine is supposed to come up there, but if you hear the ice cracking beneath you, run this way, because that sort of really brings to the fact that I'm standing on about 3.5 feet of ice, and then there's a mile of really, really cold water below me. So it's like, oh, thanks for letting me know that. So, anyways, that was actually pretty cool. So, thanks, ladies and gents. I really appreciated the opportunity. Okay, so what? There's still no open bar, is there? Damn. Okay. I am happy to take some questions. I know it's getting late. If you got to go, believe me, I totally get that. I'm happy to take some questions, and we'll do that, and I'll repeat them so everybody can hear them, and we'll go from there. Sir.
Carbon footprint of everything we bring in here from China.
Mm-hmm.
If we made it here, would there be a difference?
Okay, so the question is the carbon footprint of everything we bring in from China, and let's face it, there's an awful lot of stuff we bring in from China. If we made it here, would there be any difference? And I think that then gets to the policy of how do you deal with this, and the fact that the long-term solution has got to be an international solution. So do you either, if we as a nation decided to go low carbon, do you tax high carbon things coming in at the borders? Do you cut a deal with your big trading partners to say, we're all in this together, for better or worse, so we're all going to come down, and we're all going to go figure out how to transform our respective economies? We know this is tough. We could probably do things at a lower carbon footprint, but we also do things like we export a lot of carbon to other places and they go burn it for us. So we have got to figure out how to do this. I think something, and this gentleman brings up a great point, that this is a global problem, and to think that sometimes ask, well, geez, what can you or I do? And some smug person will say, oh, great, Titley, because I walk to work and I don't drive to work, congratulations, you've reduced the global average temperature by 0.0000001 degrees over the next century. Like, who cares? So, but this idea that everybody has got to be in this. So I think to your point, sir, that our major trading partners need to be in on this. But I would argue, it sort of gets back to my slide a couple slides ago, that America can provide that leadership. I mean, that's a belief. Maybe I'm wrong, but I believe that with American leadership, we can get there. Without American leadership, it's going to be a whole lot tougher to get there. Sir. Yes, I made it easier for the NSA. If they steal my slides, I've just made it a lot easier for them, so they don't have to bother about it. I don't know even if there is a classified version. I haven't worked in there for a long time. This just shows how lazy I am at PowerPoint. I like this format. Who has to deal with PowerPoint? Don't you hate it? Yeah, okay. So, when you finally find a template that you like, I don't screw with it. Because you saw what happened when I just played with this thing. It wasn't pretty. So I leave that alone. Yeah, no, there's nothing classified. I mean, you could use other sources and methods, and you could maybe look at things, but I mean, most of the work on this stuff is done in the unclassified world. It's done at research institutions. So it's published. It's all out in the open literature. And if you talk to the intelligence community, they're trying to like train people to read this stuff because it's like, oh, we're spooks and stuff. We don't know what this stuff means. It's like, here, hire me. I can translate it for you. So that's how that goes. Sir.
I appreciate your comments about Americans being amazing and having a leadership role. I'm wondering, you have this unique nexus of sort of military, academia, working for government. Where in those three sectors, and maybe adding private sector, do you see that leadership coming?
It's a great question. Basically the question is where in the America is the leadership going to come from? I think it sort of rotates. It sort of cycles through. Sometimes, like, the classic man on the moon, it was pretty clear. NASA was showing a lot of leadership right there. And it came from the president. Frankly, it came from President Kennedy. He said, hey, dudes, do this and, get the guy back in 10 years. The times, I could see some things in the private sector are pretty interesting. So is there going to be some private sector real, no-kidding breakthroughs like in battery storage? Not a 10 or 15% improvement, but a tripling, a factor of 10, a factor of 50. That fundamentally changes things. Guys like Bill Gates got a lot of money, if they get focused on this. Elon Musk. I mean, there's some pretty interesting people going on in there. The president lately has been showing some leadership. I worked in the administration in Obama's first 4 years. I was personally frustrated by what I thought was a lack of leadership at that time on this issue. If I went to the White House with that, I would have been patted on the head and said, don't worry about this, we've got other things we're needing to do. And it's like, yeah, I mean, I do get that. But, it didn't, I think we lost time. I think we lost 4 or 5 years there. I think the leadership rolls through. And I think, that any prediction I had of where it's going to come from would almost certainly be wrong. So then how do we encourage it? How do we encourage it in all those areas, in academia, in the private sector, in NGOs, in, sort of this 21st century philanthropy, if you will, like Buffett and Gates and guys like that, in the federal government? I mean, who here works for the federal government or has, sometime? I mean, it's kind of sucked. Let's face it, it's kind of sucked for a variety of reasons. Sequestration, furloughs, pay freezes, everybody thinks you're the GSA going to Vegas, so you got to like fill out a bazillion million pieces of paper to go travel 50 miles. It's like, dudes, So I'm not sure if the leadership's going to come from there, but that'll change. It all changes. It'll get better. And good stuff is going to come out. So it's like, how do we encourage it? They'll let 1,000 flowers bloom and then go harvest it. But I can't tell you where that's going to come from. Sir, I'm looking for some ladies to ask questions. Okay, yep. Okay, go ahead. I can't see. I got lights in me and all of this. Go ahead.
I had a question about the Apollo 13.
Mm-hmm.
And during that time, the politics were very different than today. So how do we get to that focus today, given the political situation?
Yeah, it's a great question. How do you get to sort of this, united, if you will, even if for a little bit? And it's hard because people sort of, what is it? Friends come and go, but enemies accumulate. I mean, it's sort of that. People sort of accrete grievances and slights, whether real or perceived, and it gets harder and harder and harder. So whether it's, I see, those kind of vectors that I put up here at one point. See if I can find them and not turn this thing off. Yeah. There are more different sectors of society, I think, pushing. There are several of these that have big money. Business has big money. Insurance has big money. Endowments have big money. So if you start coupling that into the political system, people. you know, what is it? In a Pew thing, climate came out like 19 out of 20, I think, give or take. And, you know, so that's people. You know, so I sometimes, when sort of asked this question, ma'am, you know, I sort of turn it around and says, so have you asked your political leadership, what are you doing to stabilize the climate? Not are you for or against a carbon tax, or are you for or against cap and trade? Don't ask them a yes or no question. It's sort of like dating and relationships. Don't ask a yes or no question. Yeah, some people know how to know. So you know, but this asks them, what are you going to do to stabilize the climate? You know, because if the voters are interested, the politicians will become fascinated because they want to get reelected. We're seeing this at the local level. A lot of times it's not called climate change. You know, the South Florida guys and gals don't call it climate change, but they sure call it recurrent flooding and sea level and what are you doing? They're doing a lot of stuff. They just don't always call it climate. So I think when there is enough forcing and frankly enough pain, we'll get through this phase. You know, you sort of look back through history and we go through these weird phases sometimes, especially in the Congress. We'll come through it. It's just, it's a waste of time, and I'm not the most patient person, so that hurts. Sir?
Can you talk a bit about how the Department of Defense responded to this body of information? So on the one hand, they have a lot of obligations and presumably are highly responsive to risk and so forth.
Mm-hmm.
They're also a top-down organization that can make things change.
Mm-hmm.
Did this impact them in ways that you're thinking of a good model?
I think, that, you know, I'd kind of give them a B. I'd probably give them a B. It is top down. You see now both former Secretary Panetta, Secretary Hagel several times, starting about October or November of last year, has talked several times about climate and or the Arctic. He has actually linked some of the energy initiatives with climate. The Secretary of the Navy says, no, they're not linked at all because the Secretary of the Navy is trying to get the budget through the House of Representatives. The Navy actually has very good zero-based non-climate arguments as to why we're doing the things that we're doing with energy. So, you know, to move an organization as top-down, as hierarchical like the Defense Department, you do need, you know, sort of the analysis, and you're starting to see it show up in the official documents that then drive budgets. Now, it says, you know, that a vision without money, without a budget, is a hallucination. So, you know, so you gotta have this, but nobody's gonna move real money unless there's been the analysis. It's not like, hey, Titley, that sounds cool, let me move a couple $2 billion. Doesn't work that way. So in things like the Quadrennial Defense Review, in these Arctic strategies, I mean, these are boring, frankly, these are policy wonk kind documents, but that sets the stage. So it's necessary, it's not sufficient. I mean, there are parts, let me see if I can find the slide here in my backups. That the other part of it is, you know, the leadership does count. So these are just some of the folks who have been working this. Admiral Sam Locklear, he is the U.S. commander of all U.S. military forces in the Pacific. And Pacific, the way we define it, is basically from the west coast of America to Africa. So he has China, North Korea, South China Sea, you know, you name it. He's got all that stuff in his what we call area of responsibility. He was asked about a year ago by the Boston Globe, what's your biggest long-term threat? And Admiral Locklear, not Titley, but Admiral Locklear said it's climate change. So for that statement, he was invited with a free round-trip ticket to the House of Representatives. To his credit, he said, hey, you know, did I stutter? You know, I said it was climate change. You know, that the House wasn't too excited about that. But, you know, and why he is saying that is because he talks to all these countries and they say, dude, you know, Admiral, sir, you know, I'm literally going underwater. This is a big deal to me. So he sees that. Greenert, he's the guy in the top center. He's the chief of naval operations now. He relieved this guy Roughhead. I talked about him. Greenert, you know, you sort of see in bureaucracies, you know, you can do something. I don't know how many people work in big organizations, be it academia or whatever. But if you see sort of the direction of the bureaucracy going and actually doing more after you personally leave, it's actually a pretty good feeling. So Greener is the guy who actually went and updated at the 5-year point the Arctic Roadmap. Now, the Arctic Roadmap said it was going to get updated. We put it out in 2009, said it should be updated in 2014. Who's worked in bureaucracies who says, oh yeah, it's a living document, right? Yeah, right, we know what that means. Or yeah, it'll be updated and it's, it's gone. So he did this. The Department of Defense is going to put out a climate change adaptation strategy. I'm told any day now. We'll see what any day now means in DoD bureaucracy. I could go around to these other guys as well. So we're seeing that it's not universal. That's why I give them a B, not an A. But I'm seeing it catch. And I'm seeing it catch. I mean, none of these guys are meteorologists, oceanographers. They could frankly care less about my community, my little tiny, 0.2% of the Navy community. They care about warfighting and the readiness aspect, and they see this as a readiness issue. So because the physical battle space is changing, so it impacts my ability to generate forces, it impacts how I'm going to use those forces. So it's coming. It's slow, but it is coming. Okay, how are we doing here? It's a couple more. I know you've asked one, sir, so I'm going to go to folks who have not asked a question. I know, that's me. Okay, so.
So it seems to me that part of what some of the defense agencies you talked about are doing is realigning their strategies and reacting to climate change. But what about reducing their own carbon footprint and things like that? Is it kind of like 100% of the people are in favor of public transportation for everybody else?
Good question. So when you look at what the U.S. Navy has done, I'll just talk about the Navy because I know that piece, and they've kind of shown the leadership on this. The Secretary of the Navy, Ray Mabus, came in I guess it was the middle of 2009, and he said, I got 3 things to do, and one of those 3 was energy. He's still there. So longevity counts in a bureaucracy, not just showing up for 6 months and then moving on. And he still has the same 3 things, and the biggest one is the energy. So what the U.S. Navy is doing has been very, very aggressive on efficiency of all kinds, on bases, on how we move sailors, on warfighting ships, on combat aircraft. And what we have found is there is no silver bullet, but there's a lot of bronze buckshot. There's 3% here, 2% here, 4% here, but you add them all up, and all of a sudden you got 25%. So we're working the efficiency part. We're also working, I shouldn't say we, I keep doing that. The Navy is also working sort of the non-traditional, like biofuels, whether it's algae, whether it's switchgrass. I mean, they're smart enough to say, let's not compete with food stocks, either directly or indirectly. That's a really bad move. But where are there either places on land or out in the ocean where simply it's not supporting human sustenance? And how do I grow that? The price per gallon, sure, it's research and development. It's a lot more expensive than just going to the pump and buying your gas for $3.50 or whatever. But like anything that starts off, it starts off expensive, and if you can bring it to scale, it comes on down. So strategically, what the U.S. Navy says is, it just doesn't make sense to take billions of yours, taxpayer dollars, and send them to people who fundamentally hate us. It's not the smartest strategy in the world. So how do you go and say, let's keep those dollars inside America, and oh, by the way, you guys all see this. This is the other side of the climate change, the energy side. This is how you get at it. And, and you all know the stories from transistors, internet, GPS, et cetera, of things that are being developed by the U.S. Department of Defense that then become not only U.S. civilian, but frankly global, just the fabric of global technology. Is the energy going to do that? I mean, there's a bunch of people that sort of hope that would be, if you really find the right thing, the killer app, if you will, and that's how you really get down to the footprint issue. So the Navy's working it. They're working it, I think, in a very clever way by very carefully not tying it to climate so it doesn't get marked up in the House of Representatives and zeroed out in bureaucratic terms. No more money can be spent on it. So, and I think Secretary Mabus has really done a masterful job of sort of walking that political tightrope to keep it going, zero-based arguments, But he knows, nudge, nudge, wink, wink, this is going to really help the climate issue. Okay, I'll take one more. Yes? Sir?
Well, we have had a global climate problem with ozone depletion. Is that fixed, and did we learn any lessons from it?
Yeah, the question was, you know, the global climate problem with ozone depletion. So the good news is, you know, there was something called the Montreal Protocol that actually kind of addressed this. We found smoking gun, the science community sort of found the smoking gun of, hey, there really is an ozone issue here. It was linked back to some very specific chemicals, chlorofluorocarbons, if you remember. There are very few manufacturers who did it, so it wasn't like trying to change the world's energy system. So it was a pretty focused problem. So some people point to that. In fact, a lot of people point to that as, hey, we can actually address these things. That would be sort of like the kindergarten problem. We now have to do the PhD dissertation. I mean, that's sort of the level, and that wasn't, at the time, it wasn't like that wasn't totally easy, and there was resistance. But now this is much, much harder. But you know, I mean, you know, somebody said, you know, we didn't finish the Stone Age because we ran out of stones. So it doesn't mean that we have to like burn every single fossil fuel to move on. It's like we will move on. It's just at what rate and how much, frankly, damage will we do before we move. Hopefully, we'll figure this out, and you guys are going to be the political impetus, amongst others, to, you know, Congress will not lead, but they can be led. The administration can be led. Private industry will do this if we put in policies that give them stability and know, you know, and they know what's coming. You know, that will then turn loose to this gentleman's question, American innovation. We can do this. Technically, we can do this. We will. Thanks very much.